Salam, peace be upon you. My name is Muhammad Laiq Siddiqui, the father of Holoface. In the part so far, we have done something severe and clean. We accepted only cyclic comparability as our single primitive, the thing we call phi, a phase valued on a circle. We refused absolute phi and spoke only in differences, delta phi, inside licensed finite windows. We earned legality through passports, coherence, identifiability ceilings, and a hard derivative ceiling called Nmax. We built a local lift, we cut when needed, we excised alias zones, we certified a domain called D, and only there we differentiated. We extracted the first public carrier, A equals D phi tilde, enforced triunity as omega, kappa, nu, built finite jets as the language, and installed lie detectors so our structure cannot contradict itself. Now we arrive at a delicate moment where two dangers wait for every ambitious framework. One danger is overconfidence. We build a beautiful machine, and then we start talking as if the machine is the city it can describe. The other danger is hallucinated precision. We compute something along a path, and because the number looks crisp, we forget to check whether the number depends on our bookkeeping choices. Today, we kill both dangers at once. We are going to merge two strengths into one final lock. The first strength is this. We must separate the closed rulebook from the open world of plays. The second strength is this. Even inside the rulebook, any accumulation we compute from A must not depend on how we chop the walk into pieces. If it depends on the chopping, we are not measuring structure. We are measuring our own accounting style. So let us speak to you, listener, like we are standing together on a hillside with a notebook. Not inside a temple, not inside mythology. And we will keep episode 14 clean. Nothing here evolves, nothing here causes, nothing here happens. We are installing conditions under which anything can be described at all. Think about a city map. A map is not the city. The map has rules, symbols for roads, rivers, elevations. It has a scale bar. It has north. If you confuse the map with the city, you will argue forever. You will say, the map says there is a straight line, so the street must be straight, even when the street curves around the building. The map is a specification for how to describe, not the described thing itself. Our episode 14 machinery is exactly that. It is a compiler specification for public structure. It tells us what counts as an input, what operations are legal, what outputs are allowed, and what invariances must hold so the output is public and not private. And now here is the second analogy, even simpler. Imagine you are walking across a desert at night with a lantern. You cannot see the whole desert. You see only a small circle of light, your window. You want to record something honest about the landscape, something others can check. So you mark your steps and you record small changes. Now suppose you compute your total change in two different ways. In one method, you count every single step. In another method, you group steps into tens and you count tens. If both are honest methods, they must agree. If they do not agree, the problem is not the desert. The problem is your counting method. This is what we mean by path and decomposition consistency. A path is a walk through a certified domain. A decomposition is how we factor that walk into pieces we can compute. In episode 14, we are allowed to talk about walks because a walk is not time evolution. It is not a story of the universe unfolding. It is simply a way to traverse a domain and accumulate what our certified carrier A says along the way. Now we need to anchor this in our language, but in spoken form. We have phi, a circle-valued phase field. We do not speak absolute phi. We speak only differences of phi inside the window. To differentiate, we build a local lift, phi tilde, which is a local unwrapped version of phi on our certified domain D. Then we define A as the derivative of phi tilde. Spoken plainly, A is the local rate of phase change. It is the first public object because it survives the fact that phi tilde itself is not unique. Change in phi tilde is what matters, not the absolute choice of lift. Now, whenever we talk about A, we must remember triunity. The same A can be read three ways: as omega, the time-like cadence, as kappa, the space-like texture, and as nu, the motion-like drift, where defined. None of these is a primitive. They are readouts, shadows of the same A in different directions of description. So what does it mean to accumulate A along a path? It means we take our path, a loop or a walk, from one point to another, and we add up the little contributions of A along that walk. In formal math, you would write an integral, but for audio we will speak it like this. We compute the total phase accumulation along the path by summing the local phase change rate that A reports step by step along that path, staying inside the certified domain D. Now here is the key. In a clean world, with clean bookkeeping, the total accumulation should not care how we break the path into pieces. Whether we sum it in one long sweep or in many short segments, we should get the same final token within our uncertainty budget. If we do not, then we have detected one of three things, and none of them is mystery physics. Either we cross the cut without declaring it, meaning our lived bookkeeping is inconsistent, or we wandered near an alias zone, meaning our derivatives are counterfeit there, or we enclosed or approached a defect, meaning the domain has a typed obstruction that must be recorded as a topology token. If none of those explanations fits, then we do not celebrate. We escalate. We mark an escape candidate because we have found a public structure that our grammar cannot encode. Now we merge this with the other lock: framework versus implementation. Here is the simplest way to say it. The compiler is closed. The programs are open. The compiler is the set of rules that tells us what counts as public structure. Those rules include: only delta phi is public. No window, no claim. Every claim carries a passport. Coherence must pass. Identifiability must support the claim derivative order. And max caps what we can say. Uncertainty propagates. Operators are guarded. Invariance under allowed redescriptions must hold. Consistency audits must pass. These are rules of the language. They are not discoveries about nature-specific content. They are the conditions for any certified content at all. The programs are the actual scientific runs we do with this compiler. Ocean waves, brain signals, market data, lab interferometry. Those are implementations. They are open. They can be endlessly rich. They can be wrong. They can be improved forever. And they do not change the compiler's rules. Why is this distinction so important, right here, right now? Because path and decomposition consistency is exactly where people accidentally confuse the two. They compute an accumulation along a path, they get a striking number, and then they start telling a story about the universe. They forget to ask, is this number invariant under admissible decompositions? Is it invariant under lift shifts? Is it robust to cut relocation? Is it stable under window refinement? If not, the number is not public structure. It is a private artifact of a particular run, a particular coding choice, a particular decomposition. So today we install the architect's discipline. We say, the framework tells you which computations are allowed and which invariances you must satisfy. The implementation gives you particular results, but those results are certified only if they pass the framework's audits. Now let us make this so concrete that a 10-year-old could feel it. Imagine we have a rope laid on the ground in a messy spiral. We want to know something about the rope's shape that does not depend on how we look at it. We can measure the rope in segments. We can measure it in one long pull. If our measurement of total length changes depending on how we segment it, we do not conclude the rope is magical. We conclude our measuring method is inconsistent. Maybe our ruler is bending, maybe we are skipping parts, maybe we are measuring different ropes. This is exactly the same logic for A. A is our certified ruler for phase change. A path is our rope. A decomposition is how we chop the rope. If we get different totals for the same path under admissible decompositions, we have not discovered magic. We have discovered the failure in bookkeeping, domain typing, or defect accounting. Now we will state the mission, the core, the gates, the prediction, and the falsifier. But we will weave them as story, not as checklist. Our mission is to force agreement. Any accumulation or transport computed from certified A must be decomposition consistent, modulo typed obstructions. In ordinary language, if we walk the same route and compute the phase accumulation, we must get the same answer no matter how we split the walk, as long as we split it in legal ways, and as long as we respect the domain and the declared obstructions. Our core is this. Even without time, walks through a certified domain must be consistent under admissible refactorizations. If not, we are measuring our bookkeeping, not structure. Now, what are admissible refactorizations? They are the legal ways of rewriting the same walk as a sequence of smaller walks, or as a different route within the same equivalence class, without leaving the certified domain and without changing the declared cut bookkeeping. If two decompositions are both legal under the same passport and the same domain typing, they must yield the same invariant token. And now we must enforce the firewall. We are not talking about the wall changing in time. We are not talking about dynamics. A walk here is a mathematical traversal of a domain, not a physical history. We can apply the same walk logic to a spatial loop, a loop in data index space, or any certified comparator graph traversal. Nothing happens. We are checking consistency of description. Now let us bring in the most powerful cross-scale analogy. At the quantum scale, think of an interferometer. You split a beam, send it around two paths, and recombine. The interference depends on phase accumulation along paths. If the phase difference changes depending on how you subdivide the path in your calculation, then your calculation is wrong. The apparatus does not care about your segmentation. It cares about the physical phase accumulation, which in our language is the path accumulation of A modulo the circle. At the human scale, think of walking around the neighborhood and counting how many times you turn left. If you count left turns by blocks or by intersections, you should get the same total for the same loop. If not, you missed a street or you double counted. The neighborhood is not changing, your bookkeeping is. At the cosmic scale, think of navigating by stars. If your final position estimate depends on whether you break the journey into 1-day segments or 1-hour segments, then either your clock is inconsistent, your star catalog is wrong, or you are mixing coordinate systems. Again, not magic, just inconsistent decomposition. So we now install the gates, but we describe them like a disciplined ritual. First, we certify the path. A path must live inside a certified domain D, inside a licensed window with a passport. This means we have already excised alias zones and we have declared cuts. If the path crosses into illegal territory, then accumulation is undefined. We do not pretend. We stop. Second, we register the decomposition. We do not allow secret decompositions. If we split a path into segments, we record how. If we rewrite it as another sequence of segments, we record that too. This is not bureaucratic nonsense. This is how we later prove the result is not dependent on a hidden choice. Third, we enforce equivalence and invariance. This is the heart. We perform stress tests. We shift the lift by adding a constant to phi tilde and confirm that A does not change. We relocate cuts when relocation is allowed and confirm that the final invariant token does not change. We refine the window slightly, staying within license, and confirm the token is stable within propagated uncertainty. And crucially, we compute the accumulation for multiple admissible decompositions of the same path and confirm they agree within tolerance. Fourth, we enforce domain typing. If a decomposition uses an operator where it is not legal, it is rejected. If a segment runs too close to an excised alias boundary, we either recertify with a caller or we refuse. Now the prediction, stated without dynamics. We predict that different admissible decompositions give the same token when domain typing is correct. If disagreements appear, they will localize to one of the known failure classes: cut bookkeeping, aliasing, defects, or passport failure. In other words, disagreement is not a new force. Disagreement is a map that points to what we forgot to type. What is the falsifier? It is severe. Two admissible decompositions disagree on the same certified domain with all bookkeeping verified and no admissible obstruction classification available. That means we have a stable, reproducible mismatch that survives every attempt to explain it as cut, alias, defect, or bad passport. If that happens, we have not found a cute anomaly. We have found a crack in the compiler specification. That is an escape candidate. That is where the framework must either expand or admit failure. Now we merge the blueprint versus CityLock into this same audit, because it changes how we talk about results. Suppose an implementation team runs the compiler on neural data and finds a path token that looks like a circulation of phase. If they immediately say, "This proves consciousness is a vortex," we revoke that. Not because the token is wrong, but because they confused framework capability with interpretation. The framework says we can compute tokens from A along certified paths. The token is a structural output. The meaning of the token in terms of consciousness is not a phi0 claim. That is a later layer question or a correspondence bridge question. So we keep the token and we reject the overclaim. Or suppose a physicist computes a loop token around a solenoid and calls it action at a distance. We say, no romance. The compiler says, check domain, check modulo, check defect tokens, check cut conventions. The loop token is real, but its explanation must be typed inside our grammar. Likely a hole in the domain and a defect token, not a mystical influence. This is how the two strengths fuse. Path decomposition consistency keeps the calculation honest. Framework versus implementation keeps the interpretation honest. Now let us give you one vivid example that stays inside episode 14. Imagine we have a certified window on a wave field. Any wave field. It could be ocean waves or an electromagnetic wave in a lab. We reconstruct phi tilde on domain D. We compute A, the derivative of phi tilde. Now we draw a loop entirely inside D with a safe color from exclusions. We compute the path accumulation of A around that loop. In spoken terms, we walk the loop and add up the phase change rate that A reports, step by step. We reduce it modulo a full turn of the circle, because phase lives on a circle. That gives us a loop token. Now we compute the same loop token again, but we split the loop into 4 arcs, compute each arc, and add them. We compute it again, splitting into 40 tiny segments. We compute it again with a different numerical scheme, still legal. If all are admissible decompositions under the same passport and domain typing, they must agree within uncertainty. If they do not, we do not invent a new phenomenon. We localize the mismatch. We ask, does the mismatch cluster near a declared cut? Does it cluster near an excised alias zone boundary? Does it cluster around a point where winding suggests a defect? Does it disappear when we refine the color? Does it vanish when we move the cut? If yes, we classify. If no, we escalate. Notice what we did not do. We did not say the loop token causes something. We did not say it evolves. We did not say it drives. We only said this token is a certified piece of structure, and its certification depends on invariance and decomposition consistency. Now we must talk about uncertainty, because otherwise our promises become poetry. Every accumulation has an uncertainty lineage. If A is estimated from data, A has noise. When we add along a path, noise accumulates. Different decompositions may have different numerical errors, but if both are legal, the differences should still lie inside the propagated uncertainty envelope. If decomposition differences exceed the envelope, something is wrong. Either our uncertainty propagation was dishonest, or our domain typing was wrong, or we are in the presence of an obstruction we did not type. So this part also gives us a very practical prohibition. Any invariant that changes when we change admissible decomposition is rejected as non-public bookkeeping output. We do not put it in the public ledger. We keep it only as a debugging artifact. Now let us install the final philosophical clarity, still inside episode 14. We can finish the compiler and still be infinitely humble about the universe. The compiler tells us what kind of speech is licensed. It tells us what counts as a valid sentence. But it does not write all poems. It does not predict which poem the universe is. It does not even promise that every domain we care about will be easy. It only promises that if something is publicly knowable, it must be expressible through this discipline, or it will falsify the discipline. So when you hear us say complete specification, do not hear theory of everything. Hear something much more precise and much more honest. Here, we have finished defining the rules of one layer of public structure extraction. And now we end with what episode 14 always demands: the audit artifact and the revocation clause spoken plainly. Here is the audit artifact we would write to the ledger for this part. We would record the window passport identifier. We would record the certified domain D summary and the color distance. We would record the path certificate, the path geometry in whatever representation is legal, plus the fact it stays inside D. We would record the decomposition registry, the list of admissible decompositions used, including segmentation schemes and any equivalent refactorizations. We would record the invariant stress tests, lift shift test, cut relocation test when applicable, window refinement test, and their pass or fail status. We would record the computed tokens for each decomposition, the propagated uncertainty for each, and the mismatch map if mismatches appear. We would record the diagnosis classifier output, cut proximity, alias proximity, defect candidate, passport failure, or unexplained. And we would record either a certified token with its uncertainty or a refusal certificate that says undefined under this passport. And now the revocation clause, the teeth, without apology. If a claimed invariant depends on admissible decomposition, it is rejected as non-public bookkeeping output. If someone presents an accumulation token without a path certificate, without a decomposition registry, without invariant stress tests, and without uncertainty lineage, we revoke it. If someone uses the token to claim dynamics, causes, agency, or meaning inside episode 14, we revoke that claim as a scope violation. If a mismatch survives all admissible diagnoses and remains stable inside certified territory, we do not romanticize it. We label it an escape candidate, and we trigger the escape protocol later. Because a true mismatch is not a miracle. It is a formal demand for either a new token or a new rule. One last note for you, listener. If you want to go deeper into the formal work behind these rules, you can find the formal papers on Zenodo by searching for the word holophase. But what we have done here is already the essence in everyday language. We have fused two disciplines into one clean lock. The blueprint is not the city, and the walk must not depend on how we count the steps. The compiler is closed, the programs are open, and even without time, paths must agree. Always, peace be upon you.